Hello and welcome to Engineer Simple. So I'll continue talking about power system bus. So as I was saying, sometimes, when you are either doing short circuit analysis or power flow analysis, or even just drawing like a one line, you represent a substation with just a bus. But what does that mean? So like I was saying, here's one way you can represent a bus: a straight bus, a ring bus, a breaker in half. So this here stands for breaker, breaker, and a half. And I showed, here's a straight bus representation, here's a ring bus. Now I'll cover breaker and a half. Breaker and a half is typically when you have multiple facilities connected to a bus, more than 5 or 6 probably, or 5, and you're going to expand the substation in the future. But let's just go with, since I have only 4 things connected to bus 3, I'll just keep 4, even if this is not practical, because 4 you can only, probably you want to just do a ring bus. So the way you draw a break and a half, basically you have 2 buses. So let's call this bus A and bus B, bus east, bus west, bus south, bus north, bus 1, bus 2, but don't confuse them with this terminology here. So then between the 2 buses, draw 3 breakers. Each leg has 3, and keep in mind there are switches here, but I'm not drawing them just so this is clean. So again, you do the same thing. And you just keep going. You draw as many as needed. So you can see you can only connect 2 terminals on each leg of the break and half. So here are 2 lines. So since I have 4, so here's another line. Here's a 4th line. So those are the 4 lines. So you have each leg of the break and half. So this is what I call a leg. You have 3 breakers, and you can connect 2 things, 2 lines or 2 transformers, capacitor banks, or shunt reactors, whatever. Then the reason it's called a breaker and a half, because you see, if I take this line, let's call this line 1. So the line 1, and let's call this line 2, just so we can represent the breaker and a half terminology. So this line here, it has its dedicated breaker, which is this one. Line 2 has its dedicated breaker, but then there's an extra breaker shared between the 2. So each line has a breaker, then they share kind of like one half of the 3rd breaker. So you have 1 plus 1/2. So that's where the terminology of breaker and half comes from. The advantage of a breaker and half, especially if you have lots of things connected, basically you can connect as many things as you have. So again, so if this bus here is faulted, somehow it's faulted to ground, or the other bus, one of them. The only thing is you're going to come here, this breaker will open, so this breaker will open, nothing is taken out of service. Now if this breaker here, say like this bus fault here, somehow this breaker did not open for whatever reason. it's going to transfer to the next breaker, this one here, which means you're going to take this line out of service. So it's only one line, and 3 lines will remain in service. Now, what if the breaker in the middle somehow, like if there's a line like this line here, for instance, let's take that as an example, is faulted to ground? That means these 2 breakers here need to open to isolate the fault, including the breaker like on the other side. But let's just stick with this substation here. So these 2 breakers need to open, but let's assume the middle breaker somehow did not open. Then it's going to transfer the trip to the next breaker. That means you're going to take another line out. So at any given time, basically you would, like in this example, so you have 4 facilities or lines connected. Out of those 4, the worst case, you will lose 2. 2 will be out of service if this middle breaker fails to open. So which is, again, it's still better than a straight bus. But if you notice, you need more breakers, so it's more labor, more property, more space, so it gets expensive. So especially if you need to like add more, say like you have more lines, transformers, for instance, you're going to add more things connected, like a transformer here, for instance, you add another one. So it's good. At any given time, you're only losing 2 things instead of almost the entire thing with a straight bus. But the thing is, cost, space, they increase quickly. So that was it for this video. So I kind of went through when you hear a bus, what is the meaning of a bus? Physically, it's not just a vertical or horizontal line. Thank you and have a great day.